Thank you so much, Doctor, for a wonderful presentation.
You're
So,
welcome.
actually, I just want to ask a question regarding one of the modeling I worked on.
I'm sorry, I can't hear your voice. Is it from my side or is general?
I think it's general.
Yeah, I think it's from your side, brother. Maybe you can try another few minutes. Maybe your network will be better then. It seems your network is breaking. Okay, yeah. Maybe you can type the remaining part through message.
Okay.
Yeah.
Thank you so much. Thank
And
you.
then later, when I start answering it, then if you have anything to add, maybe the network will have improved at that point in time. Yeah.
Okay, thank you.
Let's listen to Mr. Mohammed Balogun.
Assalamu alaikum.
Alaikum salam.
Doctor, thank you very much, sir, for the section.
You're welcome.
So I have a couple of questions. I don't know whether I don't want it to take much time, sir.
Yes,
Actually, the first one is about collinearity of data. When we have data that contains features that they have a correlation between one another. So while treating the data, if the data is actually giving us good result, is it compulsory that we'll address that collinearity, or we can just leave it? So that is the first question.
Okay.
Then also dimensionality reduction. So on that dimensionality reduction, if we have a data that is not that large, but actually we are getting good result, but the features are many. So is it compulsory that we have to reduce the features, or we just leave it like that?
Okay.
Then the third question I have is on the weaker. Whenever we put features that is categorical, I think we can undo the categorical features directly. So I just want to know what is the underlying way of the weaker at handling it, because if you are using Python, we have to maybe like look one auto encoding or other encoding what is it called, things that we can use. But what is the underlying this thing that Wika is using to handle those categorical data directly?
Okay, thank you very much. So that yeah, I can start from the rear. So starting from the Wika. So yeah, this is one of the Wika actually does a lot of things behind the scene for us because you are not using the coding. So there's no magic it is doing. It's actually the coding has been done by somebody behind the scene. You get the point now, okay? So if you have to do it manually, write your own code personally, then you have to do the coding. But in Wika, it has been pre-done, So a lot of things have been done for people. And that is why for people who don't know how to program, I say, okay, this is a place to start. And a lot of headache are taken away from you. You just need to click your model, select the algorithm, introduce your data set, do the parameter optimization or tuning, and then you get your result. A lot of headache are taken over. Yeah. But however, how are they able to do it? Yeah, a lot of programming are going on behind the scene. We call it back end. There's back end of all the GUI you are looking at in a Wika. There's a back end to it whereby you have the coding and everything has been taken care of. So if there's any data that need to be pre-coded, they take care of that behind the scene. So you only see the GUI, which make it actually easier for you to use. So, and you can actually also access the code. So there are other ways of accessing code. You might want to check it out, access some of the code of Wika and see the way it works. And hopefully also maybe build your own Wika in future and give it your own name. So come up with things like that. A lot of them, it's not only Wika, there are other no coding AI that are coming up, just trying to make it easier for people to be able to implement artificial intelligence solution without necessarily the hurdle of coding. Coding is interesting, but then not everybody will know coding. If people want to pay attention to coding, they will not understand the principle of the techniques they are learning. So this is the actually idea, one of the motivation for us to select the Wika as our preferred training kit for now, because we want everybody from irrespective of your background to be able to learn machine learning concept and also be able to build application and deploy. So I hope that clarifies that point. On the second question, and that is regarding the cost of dimensionality. Yeah, that if you are having a data set, though the number of features are many, however, even though this number of features are many, it's expected that maybe there will be cost of dimensionality problem. And surprisingly, there's no problem. You still get excellent results. Yes. Do we still need to do feature selection? Well, one, it is optional for you since you are getting your good result. Your client who gave you the data is happy. Everybody is happy. That is good. However, feature selection has its own advantages. One of the main usefulness of feature selection is to solve the problem of cost of dimensionality. When you have cost of dimensionality, it means your features are too many. The number of samples are not meeting up to be able to model it. You are getting bad result. Feature selection is going to come to your rescue at this point in time. This is one of the very popular usefulness of feature selection. However, apart from this, feature selection also has other advantages or usefulness, okay? Take for instance, if you are to collect, you just build an application now, and it has 17 medical tests. Let's say I just build a medical application to diagnose people. And this, we need people to do 17 medical tests. And I'm getting excellent results, maybe 100%. However, when you look at the cost of going to a laboratory to take 17 different medical tests, that is huge money for every patient. Do would you do that? One, this can prevent people from using an application. Oh, it's too costly. Maybe I'm going to spend like 50,000 to go and do medical laboratory tests. People will not use it. It's not. Even if the government is providing it for free, it's a waste of resources. I will now use feature selection to check. Can I actually reduce the number of features? Can I reduce it to like 5? And I'm still getting 99, 100% you are getting before when you are using all the data set. You see that it's going to save money. It's going to be even less riskier. Imagine somebody on the sick bed and you have to take like 17 blood samples, or you want to take blood samples for 17 medical laboratory tests. It's already anemic, not enough blood in his body, and we have to take more. So that kind of application can actually be rejected by medical professionals that no, this is too tough for the patient. It's risky to take such a huge amount of blood from this patient. So in that case, even though we are getting good results, we go for feature selection to make feature gathering easier, less costly, and then effectiveness is also going to be added to it. So this is another area whereby you want feature selection. Another thing is the computational complexity also. If you're having 17 features, definitely it should take time to run the experiment compared to when you have 5 features. So this is especially if your data is big. So in this case, we need a very powerful machine to be able to work with it. So in essence, in summary, in addition to solving the problem of cost of dimensionality using feature selection, it also has the problem of reducing. It's good for you to reduce the cost of gathering the features, reduce also the time complexity that is associated with many features. And of course, also, we call it lightweight. We say we want to build a lightweight model. A lightweight model means a model that is going to be fast because of very few features. It's going to be easy to also get the features ready. Even when you get the feature, entering 17 features, for example, somebody built an application online on mobile to check your diabetes status, and you have to enter 17 data. It's time consuming. A lot of busy guys will not use it. So we always want things that is good, but then people must be encouraged to use it by reducing the time they're going to spend before they are going to be able to enter it. I hope that clarified that one also. And then to the first question of collinearity, well, if the feature is linear, you work on collinearity if you feel this is going to affect. In most cases, Now, collinearity means that I have feature 1, feature 2, feature 3, feature 4. This is increasing the number of features you are having. This is increasing the number of features you are having. Sorry, I have X1, X2, X3, X4. And I told you we are expected to have like 10 raised to the power 4. Number of samples need to be increased. And we now find out that X1 and X2, they are collinear. I mean, they have a very close relationship. They're almost doing the same thing. Almost doing the same thing. So can we remove one of them for the other so that we can reduce the number of features you are going to look for? If you can do that, that might be necessary. However, in your case, you actually let the data speak. Let the data speak. Let the data speak means once you get a data set, before you start removing anything, don't delve into pre-processing too much. I think that was another video also where we explained this concept. A lot of people spend a lot of time doing pre-processing. Some pre-processing are optional. Optional for us. So let the data speak. Run the model using entire features you have. Now in your case, you got excellent results. Then you can deploy your work, report back to your client, I got it done. However, if you want to look at the advantage as just mentioned about feature selection, now you are using 4, 1, 2, 3, 4. Can I use 3 and still get the same result? If yes, it is better. Then you are going to reduce the time complexity. Even the cost of getting the features will be reduced and the cost of entering the features will be reduced. But sometimes your client say, hey, we don't have time. You got excellent result, please just give it to Rob. I want to do collinearity check and no, don't worry. It's not compulsory, but however, to get other advantages of feature selection, it's always good to do them. I hope that clarifies your question, Mr. Muhammad.
Okay, sir. Thank you very much, sir. Okay. I have a suggestion. The suggestion I have is that these materials that are shared. I hope if you can have like a Google Drive whereby we can share the link whenever any material is shared, we can always get it there to be very easy for us.
Well, yeah, thank you very much. So noted actually. So I have also noticed that one of our members also, Dr. Abdulwasi Suleiman, already also made suggestion that maybe a website could be made available that some of this useful information could be there. I think also work is already going on this. So hopefully we'll provide necessary updates as things progresses. So, and thank you very much. So suggestions for possible improvement, of course, are always needed. Welcome. Thank you very much. Our brother who started the questioning, did he send the question in? Can you try your side now again? Maybe it's good to be better. Your question.
Yeah, I saw the question in the message chat.
Okay. Is it possible to have an R2 value for training and testing of 1? Yeah, it's possible. That is your correlation. It means your system is practically predicting a solution that are two very close together. The same thing. See, the R square is a measure of, they call it the correlation coefficient. Correlation coefficient, we can have positive or negative correlation. Negative means you predict this is your Y and this is your Y predicted, Y actual. So the value may be, this one is increasing and this one is decreasing. That is going to be negative correlation. But when you have positive correlation of 1, that is unique and very rare because it means that you are practically predicting almost what is here and also what is here. They are following the same pattern of increment, decrement, or as the case may be. However, it's not enough to use R square as a means of performance measure. It's good to come up to follow with root mean square error, at least from my experience. And it depends on that area. You have to look at the literature in that area. How are they judging the performance? Except if you are the first one in those areas, then you have to establish a standard way of doing it, and other people will be using your own published work as a basis for the establishment. Because there are some areas where, for example, software engineering prediction, they have their own total means it's very different concept of performance measure, which you have to use it. However, if it is a system that is new, my recommendation for you is, in addition to getting your R scale of 1, which is excellent, R means 100%, by the way. That means your correction coefficient is 100%. So try to check for root mean square error. Sometimes also mean absolute error, MAE, it's also good. So, but at least 2. Because this root mean square error will tell you the absolute error that you are making. Maybe this was 25.6, but the output is actually 25.2. Then it will find the error between these two, which is 0.0, maybe 2, and then sum it up, find the root mean, because it's root mean square. Because sometimes the error might be negative. The squared will remove the negativity, and finally. So from my own experience, R square plus root mean square error. This is the minimum you can use. So don't use only R square, because like I said, R square is just a measure of correlation. You might still have, actually, the error might not be 0, even when you get R square 100. Your error might not be 0, but because what it's saying is that the system are so close together, the same level rate of change, everything, they are in perfect unison. That's why you are getting 100%. But then your root mean square error will indicate if there is, when you now get 0.0 error, that means anywhere you have 25, you are predicting 25. 26.5, you are predicting 26.5. It means everything is excellent, and it is possible. We've had it before, very rare, but it's a possibility for you to get 100% predictive accuracy, both root mean square error and R square. But that's going to be a very, very unique data, and also you have been able to deploy unique algorithms. I hope that clarify and answer your question.
Yes, thank you so much.
Barakallahu fi. Now, so Dr. Mujisala, can you help us with the question?
Yes, thanks so much, Prof. The questioner, I wouldn't know if she's on board. One Mrs. Rashida Abdul Mukmin.
Okay.
She actually asked that you should elaborate on the application of ML in the field of crop production. Thanks so much, Prof.
Okay. Crop production, eh? You mean the use of machine learning in crop production? Did I get you right?
Yes, in the field of crop production.
Okay. Yeah, I'll come to that. Just before I start that, I have 2 questions here. Mr. Abbas asked a follow-up question. He said, so the lower the root mean square error, the better the model. Yes. Yeah, root mean square error, and that's why when you are defining your performance measure, you have to define your performance measure, during your experimental setting. You have to tell your reader how you are going to check your model performance. So when you tell them, I'm going to use R square, you have to define that the higher the value of R square, the better. And for root mean square error, the smaller, the better, because this is measuring the actual error, difference between predicted and the actual, and then summing them together after squaring them, and then finding the square root to remove this initial square. This is what they call it root mean squared error. So the lesser you have, the better, but R square, the higher, the better. This interpretation you need to be provided inside your report to make it easier for your reader to understand. And then another question I say, Assalamu alaikum, Prof. Any difference between MSE, root mean square error, MAE, and MAPE? Yeah. So if you look at it from their formula, like I just explained, root mean square error. Root mean square error is taking it to remove the difference between one. For example, what's the difference between this and this? Difference between this and this is, since it's making one as the center and the other one is, so if this one is bigger than this, you are going to have negative value. This is why you have to square. You have to square it to remove that negative, and later also you are going to find the square root to nullify the effect of that scaring. Mathematicians, we have professor of mathematician with us, our admin, so they can tell us more about this. It's a statistical or mathematical basis that have been proven. So that, but from my experience, root mean square error and correlation coefficient is usually enough, but MAE, mean absolute error. Mean absolute error is going to take the absolute error, absolute value, and then find the mean. So usually it will be bigger than the root mean square error. But
I think we lost your voice, Prof.
Hello? Can we get my voice now?
Yes, yes.
Is it back?
Yes.
Okay, thank you very much.
You could be heard clearly, Prof.
Okay, thank you very much. Yeah. So, like I was saying, root mean square error, they are all different way of indicating the performance of your model. But from experience, use mean square error is very unique. So, by their formula, I would recommend the questioner to look at it. By their formula, actually, it's a lot of explanation about it. And how you can interpret them, they can easily be actually check out. Yeah. So, means absolute error. Mean, this one is mean absolute percentage error. You can see they're going to calculate the percentage of that error. Why this is absolute error, why this is root mean squared error. See? So, but root mean squared error is very, very popular. And there's also the MSC, mean square error. The good news is Weka will give you everything. So it's now left to you to see which one is being used in your area. And if you are the pioneer in that area, you can devise what you think should be used. But however, never use correlation coefficient alone. It can be misleading. Just like when you are working with classification problem, don't use accuracy alone to judge. If you use accuracy alone to judge, sometimes you might have bad result, but you don't know you're having bad result. So you have to use accuracy plus confusion matrix at the minimum. Then area under the curve, precision, recall, and host of other performance measures that have been established need to be used. So never use one performance measure in any model, at least two. So that if one is misleading, the other one will guide you to be able to know that, okay, what is the actual performance that we have achieved. Thank you very much. Now, regarding to the question of application of machine learning in crop production, this is a very, very nice question. And hopefully one of these days we have the opportunity to actually present application of machine learning in crop production, because we are all in need of this very important thing. The world is suffering from lack of, a lot of places reported of famine, this and that, is lack of food. So anything that can improve and increase the yield, why not? So why not? So it's an area that should call for a kind of concern and interest from all of us, actually. So there are several areas that you can actually look into. Is it in the area of, when you talk of production, every stage of production, you can benefit from machine learning, actually. Every stage of production, okay? What is even the field, starting from the planting season, identifying the land. Is the land okay? Can we replant it again? We can use predictive solution to help us to establish, is this okay? Is this land okay? What are the characteristics we should look out for? After that, after the clearing, which kind of seed should be planted there? Which seed should not be planted here? Based on previous data set, we can be able to say, okay, this side will support this seed, this one will not support this seed. Even during the planting, when you have to apply the necessary fertilizer here and there, what is the amount of fertilizer you have to apply? And what is the area that has to be covered? The advantage of it, a lot of things can be built because a lot of knowledge are needed in crop production. And one of the challenges we're facing these days is agriculture has been rendered to become something that is not compulsory. It's still very strange. In a lot of places, agriculture is supposed to be compulsory. It used to be. It's supposed to be a compulsory subject. When I was in high school or secondary school, senior school, agriculture is compulsory. You don't have option. How can we make agriculture optional, but other things that are not necessary are compulsory? Actually, it's a kind of a misplacement of priority that I feel needed to be reversed. It doesn't mean that everybody has to be a farmer, but you need to have basic knowledge of how can you farm. Some people are so blessed with environment that in their vicinity, just drop something on the ground, it will germinate. So I want to believe not everybody, especially with the depth of knowledge of agric, a lot of people now want to go into agriculture, but they don't have the knowledge. We can build machine learning application that can support these people. They can ask simple questions on this machine learning application model. How can I do this? How can I do this? It will be an integrated solution with several predictive solutions that can guide them. If you want to apply this fertilizer, apply this. Some people apply fertilizer, they don't even know the principle. They just dump it on it. Sometimes all of the plant will die. Sometimes it doesn't die, but then it has very negative effect on the food that they might not even be safe for consumption. The same thing, the use of herbicide for whatever we're using it for. Professional will know how to apply it, but people in the village, the local farmer might not know it. So a lot of system can be actually be built to see how can we use machine learning from every stage of the production system. We can benefit from machine learning to be able to have effective and correct food production practices, so that it's not only that we produce food, we should produce food also that is going to be healthy. How do we preserve our food? Several things actually might need to be handled. So maybe I'm not sure if the questioner is there or anyone that is interested in this area. I want to believe we can hopefully have a kind of a presentation section or machine learning in crop production. What are the opportunities and how can we really support? Because I'm a very strong believer in the case that in the system that there's no way we should be able to produce what we eat. This is the minimum people can do, actually. So, yeah, okay. So this is the minimum people can do. We should be able to produce what we eat. If we can do that, all this clamor for support, help everywhere is going to be reduced. But however, people live in the bush and they cannot feed themselves. So I want to believe this is a very, very important question. Thank you very much, Sir Rashida, for raising this. And personally, I'm very much interested in this area. So maybe that might be my own little way of pushing forward agricultural crop production in the right way. So we can look at every facet of crop production. Machine learning can be introduced into it to optimize, to actually characterize, and hopefully even come up with a lot of recommendation. Even before things go wrong in the farm, after this, we can predict if a plant is showing early sign of trouble, so that we can be able to counter the trouble before it becomes obvious. This is some of the things we have been using in medical area. I want to believe the crop also can benefit from it. You can have a preemptive diagnosis that, oh, this crop might show early signs of so thing. Based on the characteristics of the farm, there was rain, there was no rain, and a lot of things that can be actually tapped into, that can have a lot of insight. We call it insight in data science. Things that ordinary human being will not be able to know, but data will be able to communicate it. Last year, when we had something like this, there was this thing. That is what machine learning is trying to do. You see, last year when there was no rain for 2 months and later there was rain, we had this problem. That is what is there. It is not something that is maybe magic. No, it's not magic. We don't know the unseen. However, there are some characteristics that the environment is sending out regularly. If we can tap to those characteristics, we can make informed decisions before things become too late. Before hurricane all these kind of cyclones, hurricane, they used to happen unnoticed. But when they realized this, they went into study, install a lot of gadgets on the sea. Now, when there's going to be hurricane, few days before, there are alerts. How did they know? Because before hurricane happen, there will be some little earthquake under the sea that human being will not know anything is taking place. But with those gadgets installed, now those gadgets will gather data and send it to the monitoring station. And then they keep running predictive solution. Oh, last time we saw this, it was hurricane. And then started telling people to evacuate. And then hurricane will come, but then human souls will have been saved. So what I'm saying in essence is there are a lot of things that we can actually do and then benefit people in crop production, just like other areas are actually expressing the benefit. Once again, thank you very much. The questioner, you can kindly communicate appropriately after the class. We can see how we can take it further. Like I said, it will be my pleasure to support whatever can happen in that area, if only to improve crop production for the teeming population of the world. So thank you very much. And I think that's what we have for the day. Okay. Another question before we go, Mr. Abbas. Okay. Correction coefficient. Okay, you can see now. This is a practical demonstration of what I said. You can see correlation coefficient is 1, mean absolute error 0.00. This is excellent work. Root mean square error. Root mean square error is missing. Where is root mean square error? Yeah, root mean square error 0.00. That's almost 0%. So your prediction is so excellent. Yeah. So excellent work you have actually generated. You can see for the other method, this is okay. This is the training set, the testing set. Yeah, it's not bad. This is good. This is the okay. Yeah. The absolute, the root mean square error is 0.2, which is very small error, depending on the size of the data set you are also using. So you may also want to maybe interact with me later if you need other clarification or guide on this. I wish you all the best. I believe that's what we have for the day. Once again, thank you all for listening and for the attendance.